Have you ever wondered how someone could be a world-level genius at math without even going to college? Meet Srinivasa Ramanujan, a math wizard from India, who amazed the world with his amazing queries and solutions in maths. Here's the question for you. Can you find the pattern in this sequence? 1, 4, 9, 16, 25. Srinivasa Ramanujan was one of India's greatest mathematical geniuses. He made huge contributions to the analytical theory of numbers and worked on elliptic functions, continued fractions, and infinite series. Ramanujan was born on December 22, 1887 at Erode, Tamil Nadu, India, a small village about 400 kilometers southwest of Madras, now Chennai. When Ramanujan was a year old, his mother took him to the town of Kumbakonam, about 160 kilometers nearer Madras. His father worked in Kumbakonam as a clerk in a cloth merchant's shop. When he was nearly 5 years old, Ramanujan started studying in the primary school in Kumbakonam. Due to some reasons, he had to attend several different primary schools before entering the town high school in Kumbakonam in January 1898. At the town high school, Ramanujan did well in all his school subjects and became an able all-around scholar. In 1900s, he began to work on his own on mathematics topics of geometric and arithmetic series. It was in the town high school that Ramanujan came across a mathematics book by G.S. Carr called Synopsis of Elementary Results in Pure Mathematics. This book had a vast effect on the way Ramanujan wrote down mathematics since it provided mathematical arguments. The book contained theorems, formulae, and short proofs. By 1904, Ramanujan had begun to do deep research in a few equations. He investigated the series 1 and none and calculated Euler's constant to 15 decimal places. He began to study the Bernoulli numbers, although this was entirely his independent discovery. Ramanujan, based on his good schoolwork, was given a scholarship to the government college in Kumbakonam, which he entered in 1904. However, the following year, his scholarship was not renewed because Ramanujan devoted more and more of his time to mathematics and neglected his other subjects of college class. In 1906, Ramanujan went to Madras, where he entered Pachayappa's college. He aimed to pass the first arts examination, which would allow him to be admitted to the University of Madras. He took the first arts examination after having left the course. He passed in mathematics, but failed all his other subjects, and therefore failed the examination. This meant that he could not enter the University of Madras. Continuing his mathematical work, Ramanujan studied continued fractions and divergent series in 1908. At this stage, he became seriously ill again and underwent an operation in April 1909, after which it took him some considerable time to recover. He married on July 14, 1909, a 10-year-old girl, S. Janaki Amal. Ramanujan did not live with his wife, however, until she was 12 years old due to the customs in his family. In 1911, Ramanujan approached the founder of the Indian Mathematical Society for advice on a job. After this, he was appointed to his first job, a temporary post in the Accountant General's office in Madras. In 1912, Ramanujan applied for the post of clerk in the accounts section of the Madras Port Trust. In his letter of application, he wrote, "I have passed the matriculation examination and studied up to the first arts, but was prevented from pursuing my studies, further owing to several untoward circumstances. I have, however, been devoting all my time to mathematics and developing the subject." Even though he had no university education, Ramanujan was well known to the University Mathematicians in Madras with his letter of application. Ramanujan included a reference from E.W. Middlemast, who was the professor of mathematics at the Presidency College in Madras. Middlemast, a graduate of St. John's College, Cambridge, wrote, "I can strongly recommend the applicant. He is a young man of quite exceptional capacity in mathematics, and especially in work relating to numbers. He has a natural aptitude for computation and is very quick at figure work." Based on the recommendation, Ramanujan was appointed to the post of clerk and began his duties on March 1, 1912. Ramanujan was quite lucky to have several people working around him with training in mathematics. The professor of civil engineering at the Madras Engineering College, C.L.T. Griffith, wrote to M.J. Hill, a professor at University College London, on November 12, 1912, sending some of Ramanujan's work and a copy of his 1911 paper on Bernoulli numbers. In January 1913, Ramanujan wrote to G.H. Hardy, having seen a copy of his 1910 book Orders of Infinity. In Ramanujan's letter to Hardy, he introduced himself and his work. "I have had no university education, but I have undergone an ordinary school course. After leaving school, I have been employing the spare time at my disposal to work at mathematics. I have not trodden through the conventional regular course, which is followed in a university course, but I am striking out a new path for myself. I have made a special investigation of divergent series in general, and the results I get are termed by the local mathematicians as startling." Hardy, together with Littlewood, studied the long list of unproved theorems that Ramanujan enclosed with his letter. He replied to Ramanujan, saying that I was exceedingly interested in your letter and by the theorems which you state. You will, however, understand that before I can judge properly the value of what you have done, it is essential that I should see proofs of some of your assertions. Ramanujan was delighted with Hardy's reply. Indeed, the University of Madras did give Ramanujan a scholarship in May 1913 for 2 years, and in 1914, Hardy brought Ramanujan to Trinity College, Cambridge. Ramanujan sailed from India on March 17, 1914, and arrived in London on April 14, 1914, and was met by Neville. Ramanujan spent a couple of weeks in Neville's home before moving into rooms in Trinity College on the 30th of April. Let me tell an interesting story that shows his quick acumen in numbers. The number 1729 is known as the Hardy-Ramanujan number after a famous visit by Hardy to see Ramanujan at a hospital. In Hardy's words, I remember once going to see him when he was ill at Putney. I had ridden in a taxi, cab number 1729, and remarked that the number seemed to me rather a dull one, and that I hoped it was not an unfavorable omen. No, he replied, it is a very interesting number. It is the smallest number, expressible as the sum of 2 cubes in 2 different ways. Immediately before this anecdote, Hardy quoted Littlewood as saying, every positive integer was one of his personal friends. The 2 different ways are 1729, 1 cube, 12, cube 9, cube 10, cube. One of Ramanujan's remarkable capabilities was the rapid solution of problems, illustrated by the following anecdote about an incident in which P.C. Mahalanobis posed a problem. Imagine that you are on a street with houses marked 1 through n. There is a house in between x, such that the sum of the house numbers to the left of it equals the sum of the house numbers to its right. If n is between 50 and 500, what are n and x? This is a bivariate problem with multiple solutions. Ramanujan thought about it and gave the answer with a twist. He gave a continued fraction. The unusual part was that it was the solution to the whole class of problems. Mahalanobis was surprised and asked how he did it. It is simple. The minute I heard the problem, I knew that the answer was a continued fraction. Which continued fraction? I asked myself. Then the answer came. To my mind, Ramanujan replied. The outbreak of World War I soon took Littlewood away on war duty, but Hardy remained in Cambridge to work with Ramanujan. Even in his first winter in England, Ramanujan was ill, and he wrote in March 1915 that he had been ill due to the winter weather and had not been able to publish anything for 5 months. On March 16, 1916, Ramanujan graduated from Cambridge with a Bachelor of Arts in Research. He had been allowed to enroll in June 1914 despite not having the proper qualifications. Ramanujan fell seriously ill in 1917 and his doctors feared that he would die. On February 18, 1918, Ramanujan was elected a Fellow of the Cambridge Philosophical Society, and then 3 days later his name appeared on the list for election as a Fellow of the Royal Society of London. Then on October 10, 1918, he was elected a Fellow of Trinity College, Cambridge. However, his health was very poor, and Ramanujan sailed to India on 27 February 1919, arriving on 13th of March, and despite medical treatment, he died there after 1 year. Ramanujan independently discovered the results of Gauss, Kummer, and others on hypergeometric series. Ramanujan's work on partial sums and products of hypergeometric series has led to a major development. Perhaps his most famous work was on the number Pn of partitions of an integer nn into summons. In a joint paper with Hardy, Ramanujan gave an asymptotic formula for pen P. It had the remarkable property that it appeared to give the correct value of P, and this was later proved by Rademacher. Ramanujan left several unpublished notebooks filled with theorems that mathematicians have continued to study. G.N. Watson, Mason Professor of Pure Mathematics at Birmingham, from 1918 to 1951, published 14 papers under the general title Theorems Stated by Ramanujan, and in all he published nearly 30 papers, which were inspired by Ramanujan's work. That's the amazing story of a great mathematician, Srinivasa Ramanujan, the mathematician who inspired young people around the world to think from a new angle towards numbers. So if you could ask Ramanujan one question, what would it be? The secrets of the number series, or maybe even how to solve a difficult math sum in the exam? Let us know in the comments below, and if you learned something from the video, then please like, share, and subscribe for more videos on the lives of great personalities of the world.